Hi, welcome to this lesson on Analytical Geometry, Tangents to Circles, Part 1. Let's have a look at question 6. C, being the point negative 4, 8, is the center of the circle that passes through the points H, 2, negative 2, and Q, negative 10, M. Determine the equation of the circle. Okay, so first of all, we know that the center is C, negative 4, 8. So it's going to be X, and then the opposite sign of negative 4 is positive 4, all squared, plus the opposite sign of 8 is negative 8, all squared. That's going to equal to your r squared. So right now we just need the value of r squared, and then we are done. So how can I find that? Well, I can look at the points C and H, because those are two coordinates we know, and we can work out the distance between them. So from negative 4 to 2, that's 6 units across. And then from negative 2 up to 8, that is 10 units up. So I've got this right angle triangle here, 6, 10, and the radius. So by the Pythagorean theorem in this right angle triangle, I can say that the radius r squared is equal to 10 squared plus 6 squared, which is 100, plus 36, which is 136. So that's the value of r squared, which is what we need. So therefore the equation of the circle is given by x plus 4 all squared plus y minus 8 all squared equals 136. And that is the equation of this given circle. Next, we want to determine the value of m. Now notice m is the y value coordinate for the point Q. So I can utilize the properties that the fact that if I join Q to C and then C to H, that is going to be a diameter of the circle. So C is the center, which is the midpoint of the diameter. So I can use midpoint relation to work out the value of m here. So this is the geometrical way of doing it. So I can say from H to C, how did I get there? So from 2 to negative 4, I had to move across 6 units. And then from negative 2 to 8, I had to go up 10 units. So I need to keep that same proportion going on, because that is the midpoint. So if I go from negative 4, 6 across, I get negative 10, which makes sense. And then if I go from 8, 10 upwards, I must get m equals 18. Okay, so that is the logical argument. The other way you can do it is substitute it into the equation of the circle. So remember we found it was x plus 4 squared plus y minus 8 all squared equals 136. So if you substitute the point Q, negative 10m, we get the following. So when x is negative 10, it's negative 10 plus 4 all squared plus y is now m minus 8 all squared equals 136. So negative 10 plus 4 is negative 6, and then negative 6 all squared is 36, plus m minus 8 all squared equals 136. Then I can subtract 136 from both sides, and I get m minus 8 squared equals 100. So now if I square root both sides, I'm going to get m minus 8 equals plus or minus the square root of 100, which is 10. So algebraically, it makes sense that there are two solutions, because you can also get another point here, let's call it r, which still has x as negative 10, but now there's another value here. Okay, so depending on the value, it'll be a plus or minus. So if we have m minus 8 equals positive 10, or we have m minus 8 equals negative 10, okay, so if I add 8 on here, I'm going to get m equals 18, which is what we found our answer to be. Or you can have m equals negative 2. And again, so that's actually in line with h, which is nice. But that just means that you have two possible points, and you have to find the correct one if you use the equation to solve for m. So just keep that in mind. So there's both a geometrical way we can do it and an algebraic way. And lastly, determine the equation of the tangent to the circle at point Q. So at the point Q, there's the tangent line there. And we've got our radius line. So we know m is 18, so we can put it in there. So again, geometrically, we expect a positive gradient and a y value that's quite large. Okay, so now I'm going to say that the gradient of the radius, let's work that out here. So from negative 10 to negative 4, that's 6 units across, and then from 18 to 8, that's 10 units down. And you can see the gradient of the radius is going to be negative, because it's decreasing from left to right. So it's going to be negative 10 over 6, when simplified is negative 5 over 3. So therefore, the gradient of the tangent line, using the properties that the tangent and the radius are perpendicular, you'll find that your gradient of your tangent is 3/5, because when you multiply those two together, you get -1. Okay, and again, the gradient's positive. That's what we expected. And we also expect the c value to be positive. So y equals 3/5 x plus c. And now we're going to substitute the point of contact, which is q, -10, 18. So when y is 18, x is going to be -10 plus c. Okay, so I'm going to get 18 equals, so -10 divided by 5 is -2. So I get -2 times 3 is -6. And then if I add 6 on both sides, I'm going to get c equals 24. And again, we expected that because it's a positive number and it's much bigger than 18. So therefore, the equation of the tangent line of the circle at the point Q is y equals 3/5 x plus 24. Awesome. I'll see you in the next one.